Hi, welcome to this diagnosis tutorial on network planning for aircraft cabins. In this video, I'm going to show you how we at Diagnosis plan aircraft installations of our wireless IFE systems with the help of computer simulations. To do that, we have developed the simulator whose interface you see on the screen and that I will use next to illustrate the steps that are necessary for a proper in-cabin installation. So the first step is to select the aircraft on which we want to install a wireless IFE system, for instance the Airbus A330, which you see in scale on the screen now. And the next step is to drag the different radio frequency nodes that make up the wireless IFE network. The first element and the main element as well is the AeroBTS Plus, which is a GSM base station front diagnosis. Next, we select a network control unit, which is a legal requirement for all aircraft with this sort of networks on board. And then we select an antenna, which will be the passive element distributing the coverage throughout the cabin. This simulator supports two types of antennas, but let's just go for the very traditional dipole antenna. Next, we link the various elements, so we connect the RF output port of the AeroBTS to the input port of the network control unit, and then the output port of the network control unit to the antenna. This is only a downlink simulation I'm going to perform today, that's why we only have one transmit antenna rather than also a receive antenna. Next thing I'm going to do is to choose the lengths of the cables, for instance 1 meter for the cable linking the BTS to the NCU, and then for instance 6 meters for the cable linking the NCU to the antenna. The antenna is usually located very far from these two elements, that's why this cable is usually longer. Next, we select the frequency at which the AeroBTS is going to radiate. Let's select, for instance, a frequency channel number within the 1800 MHz band, and then the radiated power, for example 6 dBm. Next step is to activate a frequency band to be controlled by the NCU. In this case, we're selecting the same band in which the AeroBTS is radiating. And now we're going to select the target calculation that we want to perform. We can do uplink and downlink simulations. In this case, I'm just going to select downlink receive power simulation. And we can do point-to-point simulation calculations, which will give me the receive power, or at least the predicted receive power at a location in the aircraft marked by the mouse. But in this case, I'm going to select a point-to-multipoint calculation in order to give you an overall view of the coverage within the whole aircraft. And since we have two active elements, an NCU and a BTS, we need to select which one we want to calculate the coverage from. Let's choose the BTS and click calculate. We see that we forgot to specify the antenna orientation, which means that this antenna is a dipole, but it can be inclined. In this case, I'm gonna just configure it as perfectly straight, which should be okay, and again click calculate. Now we get the coverage prediction, but we see that the locations at the back of the aircraft receive barely less than minus 100 dBms of receive power, of GSM power, which is probably not sufficient to provide a decent coverage within the aircraft. So what we will do is, to solve this problem, is to move the antenna towards the middle of the cabin. See if by doing this we can bring the far locations closer to the antenna and increase the receive power. We now see that in the worst case, the lowest receive power is minus 92 dBms, which is above the very typical level, sensitivity level of minus 99 dBms. So this means that this configuration should be sufficient to provide coverage to this aircraft. Of course, there are many techniques that can be used to improve the coverage within the aircraft. In this case, I have relocated the antenna, but I could have also selected a different type of antenna. I could have augmented the power of the EuroVTS, but of course that would have the inconvenience of causing a higher power consumption. I could have reduced the cable lengths, etc. So all that remains now is to validate this theoretical prediction by means of a measurements campaign. I hope you enjoy it, and don't forget to click the like button if you find this video useful. Thanks for watching.